All right, question 4, still in the no calculator zone. It says at time t equals 0, a boiled potato is taken from a pot on a stove and left to cool in a kitchen. The internal temperature of the potato is 91 degrees Celsius at t equals 0. All right, so there's some initial condition for us. The internal temperature of the internal temperature of the potato is 27 degrees Celsius. Oh, is greater than 27 degrees Celsius for all times t is greater than 0. The internal temperature of the potato at time t minutes can be modeled by the function h that satisfies, so this is dh dt, where h of t is measured in degrees Celsius. H of 0 is equal to 91. Okay. Ho, ho, ho. It's like a Christmas problem. All right. Write an equation for the line tangent to the graph of h at t equals 0. Oh. Use this equation to approximate the internal temperature of the potato at time t equals 3. Okay, well, let's think about that. So, t equals 0. Okay, so that's one of those situations where, we can use y minus y1 is equal to m times x minus x1. But instead of using y's and x's, we should probably use h's and t's, where it looks like h is y. So h minus h1 is equal to m times t minus t1. So a little substitution there. Just looking at our dh dt instead of dy dx. So y's are turning into the top number, x's are turning into the bottom number. So here's the cool thing. We already know that h of 0 is equal to 91. So I can say h minus 91 is equal to t minus 0. And I just need to find out what m is. I just need to find out what m of at t equals 0 is. And so I can do that because I know that m is the same thing as the derivative. It's the same thing as dh dt. So dh dt at t equals 0. So I can do that by doing negative 1 over 4 h minus 27. Wait, but what's it? Oh, right. When t is 0, h is 91. So that's negative 1 over 4 times 91 minus 27. You got to do that without your calculator because it's a non-calculator. So if I was going to do this, I would do negative 1 over 4. 90 minus 20 is 70. Minus 7 more is 63, and there was one more, so 64. So this is classic. They like to give us numbers that work out nice. 64 divided by 4 is 16. That's negative 16, and so that means that this should be negative 16. So I'm curious to see how they wrote their answer. Wait, I'm not done the problem yet. Let me finish part A. So I found h minus 91 is equal to negative 16t. The minus 0 is disappearing. And then it says we want to approximate the internal temperature of the potato at time t equals 3. So h minus 91 is equal to negative 16 times 3. It's negative 48. And we'll add 91 to it. So that'd be 58, 57, nope, 47. So let's see how I did. So besides not being able to do subtraction, we're good. So let's do 91 minus 48 and be a little bit more careful. So that's 11, that's 8. So 11 minus 8 is 3. 8 minus 4 is 4. Yes, I don't know how to subtract. Okay, so h is going to be equal to 43 degrees Celsius. So that'd be an example of I was going too fast and made a stupid mistake, and so I would lose a point. Out of the three points I could have gotten for this, I only would have gotten 2. it would have been better for me to say negative 48 plus 91 and leave it there than to get 47 because I subtracted wrong. So either slow yourself down and actually, be careful with your algorithms, or leave the basic arithmetic to them. So that's part A. Let's look at part B. Use the second derivative to determine whether your answer in part A is an underestimate or overestimate of the internal temperature of the potato at time t equals 3. So this is an estimate. So now we're going to find out, essentially we're going to find out the concavity at time t equals 3. Because if we know it's concave up, if it was concave up and it looks like a cup, then our tangent line would be underneath it. And if it's concave down, then our tangent line would be over it. And so this is, depending on the concavity, this will be either an overestimate or an underestimate. So I know that dh dt is equal to negative 1/4 h minus 27. Now, something to be careful of here. This t is x, not h. H is y. So this is equivalent to saying dy dx is equal to negative 1/4 y minus 27. So if I was going to take this derivative, a y prime would pop out when we take that derivative. So before I do any further work, I'm going to distribute over here. I'm going to say negative 1/4 h plus 27/4. So now when I take my second derivative and I get negative 1/4, this does not turn into just negative 1/4. It turns into negative 1/4 dh dt. So we have to be careful about that. Oh, and remember dh dt equals this whole mess. So I can say negative 1/4 times negative 1/4 parentheses h minus 27. Now, let's clean that up. Negative 1/4 times negative 1/4 is 1/16, which is very nice. So 1/16 times h minus 27. So when I plug in 3 now, I get 1/16 times 3 minus 27. So that's going to be a negative number. So I can just say this is less than 0. Therefore, since d2h dt squared is less than 0, h of t is, I don't even need to say, I can say that a little bit more succinctly. Instead of saying h of t, I could just say h of 3.
Yeah, it's a whole deck. That's what you get.
Dang it, I made the dumb mistake. I plugged in a t value. It's h. I'm wrong. Okay, so we got our second derivative, and now we just need to plug in t equals 3. Oh crap, we don't know t equals 3, do we? But we do know that according to this problem, the internal temperature of the potato is greater than 27 degrees for all times t is greater than 0. So we are taking 1/16. Ignore the scribbled out below. I didn't screw this up before. I totally screwed it up before. I tried just putting 3 in for h. We don't know. We don't know what h is when t is 3. So I can't just put a 3 there, but I can say that we know that since h is greater than 27 for all t greater than 0,
Bro, y'all can't do that, bro.
d2h over dt squared is greater than 0 for all t greater than 0. Which means h of t is concave up for all t greater than 0. So our estimate is an underestimate. All right, let's see. For t is less than 10, an alternate model for the internal temperature of the potato at time t is the function g that satisfies this mess, where g is measured in degrees Celsius. Okay, so find an expression for g of t. Based on this model, what is the internal temperature of the potato at time t equals 3? Okay, so if I want to find out what g of t is, then I've got to use an integral. So if I integrate this, the integral of dg dt, let's see. So if I integrate negative g minus 27 2/3 d t, shoot, brain, hold on. So this is a differential equation, right? I'm overthinking this, / underthinking this. If we start with this equation, I now need to bring the g's over to the g side, the t to the t side. So this is going to wind up saying negative 1 over g minus 27 to the 2/3 is equal to, dg is equal to 1 dt. Okay, so we're going to have to integrate this mess. So I'm going to rewrite the left-hand side first. I'm going to say this is negative g minus 27 to the negative 2/3 dg is equal to 1 dt. So now when I integrate this, right-hand side, nice and easy, t plus c. We don't know what c is, but we know that. And then over on the left-hand side, I'm going to need to use u substitution. So I'm going to say u is equal to g minus 27, du is equal to 1 dg. So I could say this is, and I'll bring the negative out front, I could say this is negative u to the negative 2/3 du. So when I integrate that, I'll have negative u to the 1/3 times 3 over 1 is equal to t plus c. So then I can say negative 3 times g minus 27 to the 1/3 is equal to t plus c. So here's using our initial condition now. We know that our initial condition was that g of 0 is equal to 91. So when t is 0, g is equal to 91. So I can say that's negative 3 times 91 minus 27. I'm not going to make the same mistake I made last time, and I'm going to do 91 minus 27. So that's 11, that's 8, that's 4, that's 6. 64 to the 1/3. The 1/3 power of 64, that's what cubed gets us 64, that's 4. So that's negative 3 times 4, which is negative 12. So c is equal to negative 12. So find an expression for g of t. All right. So an expression for g of t we got a ways to go yet still. I only have 30 more seconds on this question. So we know that negative 3 g minus 27 to the 1/3 is equal to t minus 12. So now I've got to get g by itself. So I'll plug in, or I'll multiply both sides by negative. I will divide both sides by negative 3. I'll get g minus 27 to the 1/3 is equal to negative t over 3 plus 4. And then I will cube both sides and get g minus 27 is equal to negative t over 3 plus 4 cubed. And, oop, lost the page a little bit, sorry. And then we'll add the 27 to both sides and get g is equal to negative t over 3 plus 4 cubed plus 27. So we can say g of t is equal to that. Yuck. And then we want to find g of 3, right? So now I just plug in 3. So g of 3 is equal to negative 3 over 3 plus 4 to the 3 plus 27. Oh, that's going to turn out pretty nice. That's going to be negative 1 plus 4 is 3. So that's going to be 27 plus 27. And then we're going to get g of 3 is equal to 54. So 54 degrees Celsius. All right. So this last part was a 5-point question. You got 1 point for knowing to separate the variables, 1 point for doing your antiderivatives correctly, 1 point for including C and using the initial condition and finding it, then 1 point for having your g of t equation, like so solving it, and then, or sorry, 1 point for having like g and, so 1 point for getting to this point, and then 1 point for plugging in 3 and finding out that, for getting that g of t is equal to that mess, and then plus all that. So I wrote my equation a little bit differently. It's identical. It's still okay. So, whew. Lots of messes.